Hi students, today I will be teaching you all inference. Inference is a very important chapter in statistics and I hope you will learn it and you will enjoy it while learning. So it's inference. What is inference? What do you mean by infer? Infer means to give conclusion. To infer something means to give conclusion about something. Inference is basically concerned with analyzing a set of data and on the basis of the analysis giving some kind of conclusion. Now, what do we do in inference? Generally, from a population, we draw sample and on the basis of the drawn sample we make inference about the population, about the unknown population parameter. So in inference, our main interest is the unknown population parameter. You may note down this. In inference, our main interest is unknown population parameter. So parameter is a population value and inference on the basis of a random sample selected from the population. We analyze and conclude or infer about the unknown population parameter. Now inference has three parts. The method of inference consists of three parts. Number one, estimation theory. Number two, hypothesis testing. And number four, decision theory. So the main three parts of estimation, let me rub the other parts. So the main three parts of inference is estimation theory, hypothesis testing and decision theory. Now we will learn each of these theories, each of these methodologies or aspects of inference in details. Now, estimation theory is also further divided into two parts. Number one, point estimation. And the other part is interval estimation. So mainly this is a hierarchy of inference. You can write it down. Inference has three parts: estimation theory, hypothesis testing and decision theory. And estimation theory further has two parts: point estimation and interval estimation. Now we will discuss each of these in details. Now before coming to point estimation or estimation theory, let me define a few things that will be very much useful or that will be the basic tool of inference. So what are they? Let me define what is a statistic. You will require this in every line of inference. In order to do inference, you will have to take the help of statistic in each and every step. So what is the statistic? Basically, the statistic is the function of the sample values which is used as the estimator of the unknown population parameter. Now see, let me define it. A statistic is a real valued measurable function of the sample observations which does not contain any unknown population parameter or any unknown parameter. So this is the formal definition of statistic. A statistic is a real valued measurable function of the sample observations which does not contain any unknown parameter. For example, for a sample observations, x1, x2, xn, t equals to summation xi, I from 1 to n is an example of a statistic. This is a statistic. Similarly, s square equals to 1 by n minus 1 summation xi minus x bar whole square. This is also a statistic. So these are all function of the sample observations x1, x2, xn. Therefore, these are all statistics and they have to be measurable and they have to be real value and they must not contain any population parameter involved in them. Okay, so this is statistic. I hope you write it down. If you want, you can write it down. This is a statistic definition. Take a screenshot and this is the example. Now I'm coming to estimation theory. Okay. Point estimation. What is point estimation? In point estimation, from the word point we can understand that we can know it gives a pinpoint, meaning a definite point. Point estimation, in point estimation we give a pinpoint estimate of the unknown population parameter theta on the basis of the sample observations. Okay, so here we give a pinpoint or a single valued estimate of the unknown population parameter. For example, if you say theta cap equals to 2.5, this is a pinpoint estimate. Like we are directly saying this, it is 2.5. Next, coming to interval estimation. Like a point estimation, in interval estimation, we also provide an estimate of the parameter, unknown parameter, but unlike point estimation, here we do not provide any pinpoint estimate or a single value. Rather, we say that the value of theta belongs to this interval. We provide an interval. Suppose the value of theta belongs to a -1 to +1. This suppose is an arbitrary interval, I'm saying, with a very high probability. We claim that the value of the parameter lies within this interval. So, here we do not provide any pinpoint estimate. Rather, we provide an interval. Here, we provide an interval and claim the unknown parameter lies sorry. The unknown parameter lies within this interval with a high probability. High probability. So I hope if you can see this properly, and if you want, you can take a screenshot. So in interval estimation, here we provide an interval and claim the unknown parameter lies within this interval with a high probability. So this is about point estimation and interval estimation. Now if we say, why can't we just do point estimation and we take interval estimation? Because point estimation is too optimistic. Giving a pinpoint value of a population parameter sometimes can be too optimistic. So therefore we consider interval estimation. Now I am coming to some basic concepts of inference. Basic concepts of estimator and estimate. So what is an estimator? As I said, a statistic that is used to estimate an unknown population parameter is called an estimator. A statistic which is used to estimate a parametric function is called its estimator. So what is an estimator? A statistic which is used to estimate a parametric function is called its estimator. For example, T is used to estimate the parametric function g theta belonging to omega. Capital omega is the parametric space, range of values of theta. This is called parametric space.